Hi everybody, these are our notes for 5.1 day 2, which is going to be all about adding, subtracting, and simplifying. We will be looking at a total of 4 examples. And this is from our 5.1 problem set, numbers 65 to 72, odds. So starting with 65, it says 1 divided by 1 plus cosine of x plus 1 divided by 1 minus cosine of x. So just like we would with any other type of fraction work when it comes to adding or subtracting, we want to work towards having common denominators. And the fastest way to do that will be to multiply the first fraction by the denominator we see over here, and then we'll multiply the second fraction by this denominator. So what that's going to look like is 1 divided by 1 plus cosine of x times 1 minus cosine of x divided by 1 minus cosine of x. So again, using the denominator I see here, plus 1 divided by 1 minus cosine of x multiplied by 1 plus cosine of x. And remember, the intention of what we just did is to work towards common denominators, and the reason that we can do this is because if I look here, any value divided by itself equals 1. So technically you're multiplying this first fraction by 1, which doesn't change its value, and you are also multiplying this second fraction by 1, which does not change its value. Let's now use our algebra skills to simplify. 1 times anything is just what it was, so this is going to stay 1 minus cosine of x divided by. Now, when we're multiplying the denominators, you technically could use your arrows and do it that way. I'm hoping that when we see 1 plus cosine of x times 1 minus cosine of x, the 1 plus and then the 1 minus, it jogs our memory of the difference of squares, and we are comfortable immediately writing 1 minus cosine squared of x. And then here, 1 times anything doesn't change its value. And once again, 1 minus cosine of x, 1 plus cosine of x comes from, or creates, the difference of squares. We notice we've now accomplished common denominators, so I can look at what I have going on in the numerator. Now, when it's addition, it's no problem. We can literally add straight across. Keep in mind, though, that if I saw a minus sign here, I'd have to realize that that negative distributes into this numerator. I don't have that happening here, so let's see what we do next. Me personally, if I'm ever worried that I'm going to miss something, I rewrite it first, and then I'll combine like terms. If you're comfortable doing it right away, go ahead. I'm just providing an in-between step in case it's helpful to someone. So let's see. 1 plus 1 will be 2. Notice negative cosine of x plus cosine of x cancels out. So now I've got 2 divided by 1 minus cosine squared of x. So I write my Pythagorean identity over here, sine squared theta plus cosine squared theta equals 1. Now I'm looking to acquire a version of this identity that says 1 minus cosine squared of x equals something. And if I check this out, I'm actually super close. I can subtract cosine squared theta from both sides. And let's see what we get. Sine squared theta equals 1 minus cosine squared theta. And that's exactly what I need. Check it out. 1 minus cosine squared theta. I'm just going to highlight it to make it clear. 1 minus cosine squared. I now know from this identity that that equals sine squared. So I can now write this as 2 divided by sine squared theta. I'm not done yet though, because I can keep going just a little bit. I know that 1 divided by sine squared equals cosecant. So this can be simplified to 2 cosecant squared. And now I'm done. Number 67 says tangent of x minus secant squared x divided by tangent of x. So this has 1 as a placeholder in the denominator. This already has tangent of x in the denominator. So to get my common denominators, I really only have to be concerned with this first term. And I will multiply by tangent of x divided by tangent of x. I get to leave this second fraction alone, which is pretty nice. I don't have to mess with it. Let's see what we get here. This will be tangent squared divided by tangent minus secant squared divided by tangent. I now have common denominators, so I can subtract the numerators. It is subtraction, but it's just one term, so I don't have to worry about distributing a negative. And now I'm here. So we need to figure out which Pythagorean identity applies. So let's start off with cosine squared plus sine squared equals 1. Now ultimately I'm trying to get to tangent or secant, whichever one you want to see. Mentally, I know to get tangent, I would need to divide this by cosine. So let's mentally divide this by cosine and see what we get. Dividing this by cosine squared, I get 1 plus sine divided by cosine is tangent, and 1 divided by cosine is secant squared. If it helps to see it, what I just did verbally is the following. Divide each term by cosine squared, and we get 1 plus tangent squared equals secant squared. So over time, it would save us time if we can start to mentally do what we just did here, but if this is still helpful, go for it. So I've got 1 plus tangent squared equals secant squared. I need tangent squared minus secant squared. How are we going to make that happen? Well, first I see that I'm going to want secant subtracting secant squared on the other side. So I bring that over. So I now have 1 plus tangent squared minus secant squared equals 0. I'm closer, right? Here's my tangent squared minus secant squared. This 1's got to go. So I will subtract 1 to the other side. So now I know that tangent squared, minus secant squared equals -1. And that's what I need. Check it out. Tangent squared minus secant squared, tangent squared minus secant squared equals -1. So that entire numerator becomes a what? -1. You have the ability to go one more step because 1 divided by tangent is equal to, using the reciprocal identity, cotangent. And I realized I dropped a little square here, sorry. No, I didn't. My bad. Looking at a different example. Okay, I'm in good shape. All right. So this equals negative cotangent of x. And I'm done. So this is the identity that was key for us. All right. 69. Sine squared y divided by 1 minus cosine of y. Now the directions for this set are different. The directions here say rewrite the expression so that it is not in fractional form. So if you notice, I'm not adding or subtracting a fraction here, but the directions are no more fraction. So how are we going to make that happen? We need to pull a tool out of our toolbox called the conjugate, which means I'm going to take the denominator and it's going to be the exact same terms but opposite sign. So I saw a minus, so now I'm going to write a plus. And what do I multiply the top by? I need to multiply the bottom by. We're using the conjugate. The reason we do that is because every time it will create the difference of two perfect squares in the denominator, which is really nice. So let's see how that's going to work. Distributing sine squared y, this becomes sine squared y times 1 is sine squared. Sine squared times cosine squared. All divided by, notice, exact same terms, opposite sides, signs. So that's the difference of squares. So right away I know that this is going to be 1 minus cosine squared y. So I'm hoping we are recalling this tool in the toolbox from Algebra 2. It's going to be important for these next two examples. What can we do next? Well, looking at the numerator, it catches my attention that I have sine squared y here and a sine squared y right there. So I can factor that out as a GCF. Factoring out sine squared will leave behind 1 as a placeholder right there, plus cosine squared y. This is still all divided by 1 minus cosine squared y. It would have been really nice if this was also a plus, or this was minus, because then these guys would cancel. But that's not going to happen. So maybe I can use an identity. So let's see. Cosine squared theta plus sine squared theta equals 1. Ultimately, I'm trying to get rid of this denominator, right? So let's target that denominator. I can obtain 1 minus cosine squared theta by subtracting cosine squared theta over to the other side. Which results in sine squared theta equals 1 minus cosine squared theta, which is exactly what I needed. Check it out. 1 minus cosine squared theta, 1 minus cosine squared. So we get to use that now in the following way. The numerator stays the same. I haven't touched that. But now the denominator I can rewrite as sine squared y. Why is that awesome? Well, check it out. Look at the GCF you had factored out. You factored out a sine squared y. That sine squared y can cancel with the sine squared y you see in the denominator, leaving behind 1 plus cosine squared y, and we are done because we no longer have a fraction. Last example for today's notes, number 71. '71 says 3 divided by secant of x minus tangent of x. Once again, the directions are to rewrite this expression so that it is not in fractional form. I will choose to pull out the conjugate from my algebra toolbox. So I will multiply the numerator by secant of x plus tangent of x divided by secant of x plus tangent of x. Remember again, we are using the conjugate here. In the numerator, let's see what that creates. I've got 3 times secant of x plus tangent of x. I'm going to choose to just hold off on distributing. Maybe I need to later, maybe not, we'll see. In the denominator, I have accomplished the difference of two perfect squares. So that's going to be secant squared minus tangent squared. And if you're not sure, pause and prove it to yourself. Distribute this all out, combine like terms, and you'll see we arrive right here. So the numerator really isn't my concern, right? Because the directions are to see if we can get rid of this denominator. Plus, neither of these are square terms, and that means I'm not able to access the Pythagorean identities, so no real move in the top. In the denominator, though, let's see what we can do. So I've got cosine squared theta plus sine squared theta equals 1. I am trying to get to, you can either see it as trying to get an identity that's got secant in it or tangent in it, whichever one's easier for you to remember. For me, I always think tangent just comes to my mind more as sine divided by cosine. So mentally dividing this through by cosine, I get 1 plus tangent squared equals secant squared. Remember, because 1 divided by cosine is secant. So this is pretty awesome, right? Now, I'm trying to get secant minus tangent. I can accomplish that by subtracting tangent over to the other side. So now I have 1 equals secant squared theta minus tangent squared theta. And bam, that's what I needed. Check it out. Secant squared minus tangent squared, secant squared minus tangent squared. Oops. So that lets me rewrite this as 3 times secant of x plus tangent of x divided by 1, which is awesome because anything divided by 1 is just itself. So my answer is 3 times secant of x plus tangent of x, and I'm all done. Those are our odds for the notes for this video. Classwork will be the evens from this chunk of questions. If you want to give them a head start, you're more than welcome. Any questions on the video, as always, please don't hesitate to send me a remind. Have a great day.